Good evening and welcome to NASA From Satellites to Your Cell Phone, Reducing the Threat of Mosquito Transmitted Disease. I'm Dorothy Stoltz with Carroll County Public Library. I'm also the board president for the Maryland STEM Festival. And this is a Maryland STEM Festival event. The festival is a month-long celebration of STEM, science, technology, engineering, and mathematics. And it'll run through November 14th. And I'm wearing one of our t-shirts just to show it off here a little bit. You can find local events in your community. Some of them will be in person, some virtual, if you go to the STEM Festival website. Thank you to our sponsors, NASA and the Maryland STEM Festival, and to our hosts, Carroll County Public Library and the Maryland State Library, along with our co-hosts, the Cecil County Public Library, Howard County Library, Montgomery County Public Libraries, Talbot County Free Library, and Wycomico Public Libraries. I'd like to introduce Carrie Sanders, who is the Youth Services Coordinator for the Maryland State Library, where she provides consultation and training to youth service coordinators for all Maryland public libraries in the areas of early literacy skills, media mentorship, STEM and STEAM programming, teen services, family engagement, and other initiatives surrounding youth services. So let's welcome Carrie Sanders.
Thank you, Dorothy. It's a pleasure to be here with all of you this evening. Welcome. The Maryland State Library is so pleased to participate in the Maryland STEM Festival once again this year. Dorothy mentioned all those areas of youth services, and what I love about STEM is that it really encompasses all those areas. We can engage our youngest library customers, our little ones, all the way up through teenage and family events with STEM. So it's so exciting to support the festival. And we love to provide programs, library programs, virtual and in person throughout the year, not just this month of the STEM Festival, but really throughout the year, all types of different topics that we cover in different age groups with STEM. So it's lovely to be here. I do want to just mention Phil Rogofsky, who could not be with us this evening, but we are just so pleased that we have been able to work with Phil over the last few years to support the Maryland STEM Festival through Maryland Public Libraries. Phil is the founder and the executive director of the Maryland STEM Festival. He's very proud that the festival has become a connective tissue for Maryland STEM community, and just give him lots of thanks. And now it is my pleasure to introduce to you our guest speaker from NASA this evening. We are thrilled to have with us tonight Dorian Janney, who is a senior NASA Earth Science Education and Communications Specialist. Dorian is passionate for sharing the wonders of NASA science and exploration with others across all age levels. For over 3 decades, she taught public school in both special and general education settings across all age levels. She was an Einstein Fellow finalist and achieved National Board certification in science education. She has served on numerous education working groups, and she wrote science curriculum for the country. She now serves as NASA's Global Precipitation Measurement, GPM, Missions, Education, and Outreach Coordinator. And she develops resources to help share the science, technology, and real-world applications of GPM with others. She is a mentor Globe trainer, a member of the Globe Education Working Group, and supports the Globe field campaigns. Her most recent project is leading an effort to engage lifelong learners with the Globe campaign's citizen science efforts, which we've embraced across Maryland as well. It's so nice to have you with us, Dorian. We are so looking forward to this presentation and next week's. Thank you for being with us tonight. I need to step away in about a half an hour to go host another meeting, but I will be back next week, and I hope so many of you can rejoin us next week for Dorian's second program with us. So Dorian, I'm turning it over to you. Thank you so much.
Hey, thank you so much, Carrie. and Dorothy as well. It is truly an honor and a privilege to be here. I was born in Maryland and raised in Maryland. I went to Maryland Public Schools and University of Maryland, and I also later in life returned to school to get a second master's degree at Johns Hopkins in Maryland through the Maryland Space Grant. So I really feel like I'm just a Maryland girl through and through. And I kind of just got bit by the science, technology, engineering, mathematics, and of course lots of other things as well. But I got bit by the STEM bug a while back, and just have continued to be absolutely immersed and engaged in kind of all things STEM. So I'm coming to you from kind of a different background, somebody who went into education, special education, and worked with actually young preschool and early childhood programs, and then just kind of kept falling in love with learning a few more things and falling a little bit more in love with science and engineering and technology. And now here I am working at NASA. So what I'm going to tell you about this evening, and I hope to be able to make this accessible to all age levels, is tell you this kind of really neat science and technology story that involves engineering and math and reading and writing and all kinds of things, that looks at I like to call it what's the buzz, from NASA satellites to your smartphone. And on the left-hand side, you see a picture of the Earth observing satellites that NASA and many other countries around the world support, that are also related to NASA. So many countries have satellites up in space, and many countries also work closely with NASA and have satellites in space. And these satellites in this picture are satellites and include some instruments on the International Space Station that are helping us better understand our home planet. And that's something that sometimes takes people by surprise. When they see NASA, they instantly think of astronauts and the moon and space. And of course, we do all that. But we also do some absolutely incredible and super important work to better understand our home planet. So today I'm going to be telling you about how we work to better understand the world's most dangerous animal using satellites, and then I'm going to tell you how you can be a part of citizen science efforts. All of us are scientists, and now that all of us have these incredible data collectors, these smartphones, we can all be a part of gathering and sharing data that's really, really important for the health of not only our planet, but for lots of the living things on our planet. So welcome, fasten your seatbelt, and I look forward to sharing this with you. And feel free to ask questions. We will stop in the middle of this presentation after the part about the satellites, and I'll take some questions, and then we'll stop at the end as well after I tell you what you can do with your smartphone technology to help, and I'll take more questions as well. And just as was said earlier, I am a former educator, taught in the Maryland schools for over 30 years, and now I work for NASA with the Global Precipitation Measurement Mission, which I'm going to tell you a little bit about, and then also with something called the GLOBE program, which is basically a way to get students, teachers, scientists, and citizen scientists all involved in helping us keep our home planet sustainable and healthier for all of us. Well, to start this off, I want you to kind of, I'm going to ask you a question, and you don't have to answer it, but just to get you thinking. Did you know that NASA satellite data are being used to help predict, monitor, and respond to the world's most dangerous animal? So some of you, like I say, may not have even known that we studied Earth, and you probably didn't know that we're helping to be able to look out for this world's most dangerous animal. So think about, what is the world's most dangerous animal? Of course, lots of times people think sharks and snakes, and you think about kind of animals that you could imagine are pretty dangerous. But as it turns out, the world's most dangerous animal is the mosquito. Now, I don't want you to go worrying that the next time you get bit by a mosquito that you are going to die. Unfortunately, some people who get bit by mosquitoes do get diseases that mosquitoes can transmit, and that is very dangerous. But the good news is there are over 3,500 different species of mosquitoes, and only about 100 of those species can transmit disease to us. So before we go much further, I need to give you a little bit of information about mosquitoes and their life cycle. Mosquitoes are pretty interesting, and like moths and butterflies, they go through a metamorphosis. They change from one type of aquatic organism to where they're a flying insect. So the way this life cycle works, we're going to start over here with the adult mosquito. And when you get bit by a mosquito, it's always going to be the female that's biting you. And she's not biting you for food. She goes to plants and is a pollinator, an important part of our environmental system. She goes to plants, as do the male mosquitoes, for their food sources. But when she has eggs, she needs to have her eggs have a blood meal in order for them to be able to survive. So once she has her eggs, she's a good mom and she looks for some sort of a warm-blooded animal, often you and me, and she bites us. Now, it's when she bites us that the disease can be transmitted, because when she bites, she spits in a little bit of an anticoagulant to have the blood run from our veins so she can get as much as she needs. And when she does that, sometimes, in some occasions, with some species of mosquitoes, that can leave behind this disease-causing agent. So once she bites us and gets that blood for her eggs, the next thing she needs to do is lay her eggs. She wants to lay her eggs in fresh water. Sometimes it can be kind of in some bay, swamp, some brackish water, but usually she wants fresh water, and she doesn't want a lake because the lake or the river has running water, and they also will have a lot of different predators, fish and things that will eat her eggs. So what she really prefers are little places where there's just a little bit of water, or where when it rains, there might be some water so that her eggs will survive. Now, those eggs can sit for 6 months, maybe even a year. They can dry up and then wait until there's water to rehydrate them and until the temperatures are warm enough, usually around 60 degrees for a couple of days Fahrenheit, for mosquito life cycles to be active. So those eggs can sit there for a while. Now, once the eggs hatch, and they have to hatch in water, they quickly go through the rest of this life cycle. They're larvae for about 7 days. And while they're larvae, they can't hurt you at all. They're little wiggly kind of wormy things that live in the water. And they go through 4 stages there. It takes them about a week, especially if the weather's warm. And then they become a pupa. And they're only a pupa for about a day or two. And then out comes the adult mosquito. So now you all have Mosquito 101, and you'll see in a little bit why that's important. Now, I've told you a little bit about the story of mosquito life cycle. I'm going to tell you a little bit about the Global Precipitation Measurement Mission, which is this amazing mission that's measuring rain as it falls and snow as it falls to Earth, pretty much everywhere on Earth. And it does that every 30 minutes. It gives us a new update, new information. And so you're going to tie together how we can use data from this satellite and other satellites too to help us predict, monitor, and respond to mosquito-transmitted disease. I'm going to start off showing you a short video.
We plan our lives around rain. We always want to know when and where and how much, not just for our weekend plans, but for how we make decisions about our safety and transportation, our economy, or our livelihoods. So, how do we measure rain? Well, we can set out a rain gauge, like this one, and it measures the amount of rain that falls over time. The problem with this is that it only measures rain in one very small spot. In fact, if you took all of the rain gauges in the world, packed them together, they would fit into 2 basketball courts. Now, we can cover more ground if we use radar. Radar sends out a signal, and it measures how much of that signal is scattered by rain or snow. But radars are only available in certain parts of the world, and many countries just don't have access to that technology. And that's just on land. Think about how we're going to measure rain over all of the world's oceans. Look, the point is it's impossible to cover the entire Earth with enough instruments that are going to give us accurate precipitation rates for the whole globe. So we have to think bigger and higher. Instead of having a patchy network of rain gauges and radars, we could have a whole constellation of satellites looking down at the Earth, measuring things like falling rain, snow, and even ice. The Global Precipitation Measurement Mission, or GPM, is going to do that, and it's going to give us precipitation rates for the whole globe every 3 hours. Now, GPM is going to cover it all, from land and oceans, from the tropics to the edge of the poles, over mountains and valleys, from our farmland to our cities and towns. We're going to need more than a perspective on the ground if we're going to look at precipitation from a truly global standpoint. And GPM is just the mission that's going to give us that big picture. We plan our life.
Are we going? I really love that video because I think it shows in a very artistic way how we and why we measure precipitation from space. So of course we do have rain gauges all over. I have one in my front yard, and when it rains, I go out every day and I see how much it rained. But most of Earth's surface is covered with oceans, and we can't just have rain gauges out there floating all over the ocean. So a really great way of doing it is with a satellite. And fortunately, there are 9 other satellites up in orbit, many of which are from other countries, that are able to use an instrument that they have on board that measures microwave radiation. And they share all of that data with the GPM mission. And because of that, we're actually able to get an updated measurement of how much rain and snow is falling all over the world every 30 minutes. Initially, it was 3 hours, and now it's 30 minutes. This is looking at the precipitation from last week. And what we're seeing here, you can see the key down in the bottom right, is we're noting that, let me play it again, when the precipitation is falling, and we'll see it's always where we see these different colors, we see that we're also getting a feel for the wind and the wind speed. And we're able to see that precipitation is moving because of the global wind patterns from west to east in the northern and southern hemispheres. And then it's coming back kind of like a conveyor belt over there at the equator. So by being able to measure exactly how much precipitation is falling anywhere in the world, imagine now how we could tie together the GPM mission and mosquitoes. How could knowing when, where, and how much it rains help us predict outbreaks of mosquito-transmitted disease and where they might occur? So I have for you, and we'll put a link up that you could go to if you don't have your smartphone ready to shine it on this QR code. I have a little, it's called a Padlet, and some educators showed me some of the amazing technology that they began to use when, due to the pandemic, they were needing to do a lot of educating, virtual education. And so this is something you can go to, and for the next, you'll have about 5 or 6 minutes to be adding your answers to how you feel that precipitation might impact mosquitoes. So go ahead and put your answers up there, and we're going to take a look at what your answers are in about 5 minutes. And we're not going to go through all of this again, but I just wanted to put this up here to show and remind you that, so we've got our adult female mosquito. She's looking for a place with standing water to lay her eggs. The larvae have to be in an aquatic and a water environment, and then they hatch. Another thing that needs to happen is after the adult mosquito lays her eggs, she needs some vegetation to rest on because she's kind of tired after that. So she's looking for some vegetation. So you might think about ways in which precipitation affects growing things, vegetation, trees and shrubs and bushes and flowers. So NASA data, we can't use NASA satellites to be able to see mosquitoes. We're good, but no satellite is that good. But what we can do is we measure precipitation, how much rain and snow is falling. We also, with other satellites, measure soil moisture. By flying overhead and using remote sensing, we can see in the first 5 centimeters of soil how wet or dry it is. That helps us also with understanding where mosquitoes might be. Vegetation types we can measure. Surface temperature, and I told you how important temperature is. One of the things I love here in Maryland is that we have seasons. My sister lives in Florida, and there we have active mosquitoes all year long when I visit her. But here in Maryland, now that we're getting some cold nights and mornings, it makes me kind of happy because I get annoyed when finally it's nice in the evening and I go out on my porch and I'm slapping at mosquitoes that are biting me. So that's a nice thing to know with temperature that has an impact on mosquitoes. And we also can measure humidity. All of those are different environmental variables that we measure using satellite technology. So here we're going to look at, and remember to put your answers in while you're watching this, why does NASA study Earth?
When you think of NASA, you probably think of astronauts, satellites, Mars rovers, and telescopes that study distant planets and far-off galaxies. So why does NASA as a space agency study Earth? Because it's a planet too, and there are a lot of advantages to monitoring the only home we currently have, from space. Just 3 years after the space age began, NASA launched the first satellite to monitor Earth's weather. It was the beginning of a revolution in weather forecasting and laid the foundation for the global study of Earth. Today, NASA's fleet of Earth-observing satellites is essential to helping us understand how our planet works. We're trying to answer some very big questions. How is Earth changing? What's causing these changes? And what does the future hold? The answers are critical to human life and civilization as we know it. Adding to what we learn from satellites, NASA also makes regional observations from airplanes and ships. Our scientists collect even more data on the ground, and others use computers to model what's happening now and in the future with the land, ocean, and atmosphere. Altogether, it's called Earth System Science, and NASA is a global leader in the field. Best of all, NASA shares what it learns with researchers and agencies throughout the world. Because when it comes to understanding Earth, space is the place to really know a planet. And that's exactly where NASA is. When you think of...
And now, as I promised you, we're going to take a look and see what kind of answers people may have given us for what is that relationship between mosquitoes and precipitation. So here I see that somebody said it increases the number of mosquitoes, and indeed that is right. That's really important to help us know that where there's a lot of precipitation, and funny enough, also we see outbreaks of mosquito-transmitted diseases in places where there's drought. It really surprised me when I learned that from a NASA researcher, but apparently there's a couple reasons. One reason is that when there's drought, people that live in countries where they don't have easy access, or even in the United States where they don't have easy access to fresh water by turning on their faucet, and they need to collect water from outside, they put rain barrels and things to collect the precipitation and the rain when it falls. And that creates a lot of habitats for mosquitoes close to their homes. Sometimes too, their animals die off and there's not as many animals for the mosquitoes to bite, so they come and bite people. And sometimes they'll also bring their animals closer to them, the animals that they still have. And again, you've got that problem then of having the more animals around and more attracting to the mosquitoes. Someone said the more it rains, the more chances that a mosquito has to lay their eggs. And that's exactly right. Let's see if I got anything else. More precipitation equals more mosquitoes. That is definitely true. So good job. And if you want to continue adding information, this is something that I continue to take a look at and add information to when I give presentations. So feel free to continue to add info. Before I take questions, the last thing I wanted to tell you is that in the video we saw before, it mentioned that researchers use the data, but we also show others how to use the data and how easy it is to access. And all of our data is free to access. That's a part of what our taxes help to provide. So it's free to anyone, and we show them how they can access data and use it to help with all kinds of different situations and problems we have here on Earth. And this is a website that if you go to this website, and a little later I'll put it in the chat box, it will take you to a workshop that we had and some trainings and a lot more information about what researchers found out about how you can use satellite data for helping us to better predict, monitor, and respond to lots of different diseases, vector-borne and mosquito-transmitted, as well as waterborne disease. So kind of a neat application. All right, before I tell you how you can use your smartphone technology to help you with this, I want to see if there's any questions.
Yes, we have a question. Somebody is asking, what does the GPM stand for?
Well, great question. So GPM stands for Global Precipitation Measurement. So that we like to give our satellites missions kind of easier names than Global Precipitation Measurement Mission to say each time. So GPM is just kind of it's our acronym for that mission. Thank you very much. Good question.
The next question, somebody was curious about how you work with these other countries, and do the other countries have something like NASA, within how they have their satellites in space?
What a great question as well. So yes, they do. Most other countries have a space agency of some that has a special name, but is their space agency. The Global Precipitation Measurement Mission and the mission that came before us called the Tropical Rainfall Measurement Mission. So of course we called it TRIM. Both of those are co-ventures with JAXA, which is the Japanese space agency. So most other countries have space agencies. I also do some work with Nigeria's space agency. And what we do is, because we're studying Earth, and really even with our space studies as well, we work collaboratively with scientists and researchers and people who are using our data from all over the world. That's just a part of my everyday work, is that I work with people from other countries. I'm very fortunate in that, for the most part, the language of science is English. So most of the meetings and most of the resources that we have are initially in English. And then of course, other countries are welcome to translate the information as they would like. So basically, we meet, we do a lot of work virtually even before we had COVID, because we are interacting with people from all over the world. And right above my desk here, I have a map of the world that shows time zones, because that's one of the things I have to really keep in mind. And I keep not only a computer schedule, but also a paper schedule, because I do work with people from lots of different time zones. I have to be cognizant about that. So fortunately, the time zone barrier for me is really the biggest challenge for us. And otherwise, we're all working together for this beautiful home planet that we have. And we share our data, we collaborate, we cooperate. And it's really a nice space to be in.
The last question we have for now is when do those other countries present programs like that, and how are they getting students and others to participate in the citizen science?
Really good question too. And you'll note I put some links up here. In a little bit after I do the next half, I'm going to put some more links up. There's a wonderful program called the Globe program. And I hope I also, I'm going to invite you, and I hope you will take me up on downloading the free app on your smartphone that is called Globe Observer. And this is basically a program that has been going on now for 26 years. It is sponsored by NASA, but it's a joint effort with NOAA, the Department of State, and the National Science Foundation. And what we do is this program is in 126 different countries now, all around the world. And we collect different kinds of data following certain, we call them protocols. That means directions, so that we're all collecting data in the same way. And then we share that data. So that, let's say I'm wondering about whether or not, with the flooding that's happening right now in this past week in India, how might that impact not just mosquito transmitted disease, but other diseases, as well as landslides. So all of the data that we have from our satellite mission is up there and available to people in those countries. And they are able to, get in there and access our data. And then students and teachers and scientists and people in countries who respond to things like landslides and disease can also look at all of this data that people are collecting with their smartphone technology and sharing, and they have that data available to them because scientists can't be everywhere at once. And it's cool that we have these satellites that can collect all this data, but sometimes the satellites might not know the difference between, say, a cloud and snow. And sometimes when we're looking at something as small as mosquitoes and where the different places are that have standing water, we sure can't see that with a satellite. So we need the individual data from citizen scientists to add to that bigger database.
Excellent. Thank you very much. It's all the questions we have for now.
Excellent. Well, you'll see the links that I have put up right now. The first one is going to take you to an education web page that has all kinds of neat videos and activities and lesson plans. It's not just for teachers. It's designed to have kind of 4 basic pillars that are related to the Global Precipitation Measurement Mission. Then underneath that is one that focuses on, okay, this is cool. We have this data from the Global Precipitation Measurement Mission. Who's using that data around the world? So we have some neat STEM interviews, lesson plans, videos to help you better understand that. Then I put up there the link for the disease initiative in case you wanted to see a little bit more. That's kind of more scientific, but some of you might say, hey, I'm really interested in what kinds of NASA data I could go and access to find out more about where to predict these diseases. And then the last link there is a link that has a couple of different videos that tell the story of how we collect these data with NASA, and then some of the scientists as well as some of the researchers who are taking that data and using it to help with disease. So thank you so much for putting those up there. All right, let me now move to the second part, and this is where you get involved. So I hope that you will consider going to your app store and downloading the free NASA-sponsored Globe Observer app on your smartphone or your iPad. You do have to, this doesn't work on a computer. It does need to be on either an iPad or a smartphone. And what we have now on this app are 4 different tools that you can use, and we walk you through all the directions for each of these tools. You can use them to help us better understand clouds. Another tool looks at what I'm going to show you, mosquito habitat mappers, so the mosquitoes. Another one's looking at land cover, and you're just taking pictures, and sometimes if you want to, you can also tell what kind of land cover you're seeing to help us get a feel for how is the land changing. And then the final one is where you go out using your smartphone and you measure the tops of trees to help us better and understand our tree canopy here on Earth. So with the mosquito habitat mapper, and like I say, all the directions are in the app, so it'll walk you through it. There are 4 steps. You don't have to do all of these steps. You only do the ones that work for you and that you have time for. Lots of times when people first start with this, they do the first step and the last step. And also when there aren't mosquitoes, when they're not active, when it's colder, you usually just do the first step and the 4th step. And when we actually have mosquitoes, that's when you'll do some of the other steps. So let me show you about it. The first step is basically you're just observing. You're finding standing water. In the picture to the left, that's my older sister, and she's looking in this kind of pretty hanging thing that's in her yard. And it turns out that that little hanging thing that's a decoration is open inside. And so when it rains, it's a perfect place for standing water to be. And nobody would usually think of emptying it because it's not really like a bird bath or a water bowl, but lots of mosquito babies in there. So my sister's using the app and she's just taking a picture of it. Something really important when you take these pictures is we don't want pictures of people. We only want pictures of the habitat. So that's part of the directions we have. This is not the time to take selfies or pictures of your sister. I'm just showing you how you do it here. Basically, you're taking pictures of the place where the standing water is. Now, over on the picture on the right, you see that we see some kind of empty planters and maybe something that somebody had a flower pot with, and that was laying there. And when it rained, it collected water. But over behind it is a big ditch that's also full of water. Both of those are potential mosquito breeding habitats. Now, some of those you could empty, but it would be really hard to go over here unless you were kind of in charge of that area and you were making some big changes to the land to say, empty that ditch. And you'll see why that's important in a minute. So the first step, and you can do this all year round, is to take pictures of standing water. The next step is, let's say you look in that water and you see little wiggly things that might be larvae. We show you what the larva would look like, and then you can take a cup and scoop it in there, or a bulb syringe like you use when you're basting your turkey. Only don't use the one that you use for basting your turkey. Grab another one at the store. They cost just a couple dollars, and use that one for your mosquito larvae. And then you put them into a cup or into a baggie, and you take them inside because there might be biting mosquitoes outside there. And then you try to count how many larvae you can see, and maybe also how many pupa that you see in there, because that helps us to know about how many mosquitoes are in that area. Now, let's say you find mosquito larvae. Now, like I said, you've come inside where the mosquitoes aren't biting you anymore, and you sit down and relax. And here's my nephew and a friend of his, and you can buy these inexpensive cell phone magnifiers, and you just stick it on the camera of your cell phone, and it actually turns your cell phone into a microscope. So here's my nephew, and he and his friend are looking at the larva on a white paper plate. Remember, the larva can't hurt you, just the adult female mosquitoes can. And over here, I have some high school girls I was working with at Largo International School in Prince George's County Public Schools. And they're looking at what we have is a key that tells you how you can look and identify the kinds of mosquito larvae, because they want to find out, are the larvae that they're finding one of those species of mosquitoes that do transmit disease? And like I say, the larva can't hurt you, and we'll walk you through how you can use that little $6-7 cell phone magnifier to be able to figure out what kind of mosquito you have there. And then, like I was telling you, if you do find larvae, you want to try to empty out that water. And let's say you don't find larvae, but it's active mosquito season, it's still a good idea every week to just empty the water out, whether it's in a bird bath or a horse trough for water. You want to have water in there, but you want to make sure you're checking it once a week during the warmer months, when that might be a perfect place for you accidentally to be having mosquitoes that are close to where you're living. We're not trying to eliminate all mosquitoes. There would be no reason to do that. But we are trying to use the One Health approach, which brings together the environment and animals and people, and try to make sure where people and animals are living closely together, that they're making sure that they're not accidentally creating human created places where you're going to have a lot of mosquitoes that could potentially be making you sick. I'm going to turn my sound down for this, and I've gotten myself a note to remember to turn my sound back up, and I'm just going to walk you through what this would look like. So give me a second here. Let's make this go. I'm just turning the sound off because it plays some music, which is very nice, but it's kind of annoying to talk through. So the mosquito habitat mapper, here we have a gentleman, and he is sitting on a park bench, and he gets bit by a mosquito. And he knows that if you're being bit by a mosquito, there's probably standing water nearby because mosquitoes can't travel very far. So sure enough, he looks over and sees an empty flower pot. He takes his smartphone, he has downloaded his Globe Observer app, and he opens it up, and he says, I'm going to do a new observation. It uses your location, and it can see where you are and when the time is. We're not interested in necessarily who's collecting this data, but we want to know where you are. Then it's going to take you through this kind of key to find out what kind of container is this water in. So he says it's in a human created container, and he is looking here and he's, I think it's a flower or a plant pot. We're actually that specific. Next, he's going to take a picture. And of course, he's just going to take a picture there of the water that's sitting there in that flower pot. And if he sees any larvae that are in there, he might go closer in to get a closer picture of them. But he can see there that perhaps those are some larvae. So he's going to look a little more closely. And there he's going to say he's not exactly sure. But then they showed him what the larva looks like. And he says, okay, these were not larvae that are here. So he's going to, if you want, you can add additional comments, but you don't have to. He might say, he said there's no larva present. And now he's going to take it and do that fourth step, eliminate that water source so that there's not a chance then of having mosquitoes. You can collect all this data without internet connectivity, but when you get ready to send the data in, that's when you want to make sure that you do have internet connectivity. So those are the different steps. And again, you don't have to do them all. All year long, you can identify potential breeding sites, sample and count, identify larvae if you have that little magnifier, and eliminate the breeding sites. It really is very, very easy to do. And once you kind of get in the habit, I like to use Monday, Mosquito Monday, to go out and just take a walk around my yard, or if I'm taking a walk around the neighborhood, and just get a feel for, do I see any standing water? And even when it's not warm enough to have mosquitoes, I still like to be in the habit so that I'm being aware of where there could be potential mosquito habitats. So it's really easy to download, to use. It's a great way to engage your community in reducing and eliminating potential mosquito breeding habitats. Tires that are sitting around, paint cans, coffee cups, little pieces of plastic, what do you call those? Covers for your grill. All of those are places that are potential mosquito breeding habitats. At my sister's house in Gaithersburg, we were constantly being bit by mosquitoes. And it turned out she had a window well where during the summer, when we have those heavy storms and it rains a lot, there was a lot of water collecting there. And we found thousands of mosquitoes. Now, we couldn't necessarily get rid of the water that kept pooling there, but she could make sure that she was treating it with something in Maryland they have that's called dunk, that doesn't hurt any other animals at all. Of course, there were no fish in her window wells, but it doesn't hurt you or the environment, but it does kill the mosquito larva. And another thing you're doing is you're raising public awareness of the threat of mosquitoes and helping them understand what they can do to reduce this threat. I'm going to put a couple more links in our chat box. And then, of course, I'm going to stay right here and see if there are any more questions. And so, whoops, I didn't mean to do that. Come back there and put these links in here. And that is what I had to share tonight.
Well, that is so interesting. And we have a question, kind of like just a little bit more of the how to in using the app that uh, you had said that the data is stored and then you can transmit it. Just wondered if you could talk a little bit more about that is the question.
I sure can. Yep. So what happens is, and sorry, I just realized that I was not on full screen. What happens is that when you submit your data, it is then available to anyone, including yourself. Now, when you take your pictures, though, the pictures are screened by people. We have some of us folks on staff who every week we have a certain day when we look at the pictures that come in because we do want to make sure that there's no pictures of people, because again, we're not trying to get selfies or pictures of people. We make sure that they're just pictures like they're supposed to be of clouds or of these, water containers, whatever tool you're reporting on. So then we'll take a look at those, and once we ensure that they don't have people in them and that they don't have like show us, where somebody some license plates and things like that, we put them up, and then let's say I want to find out if where I live in Damascus, Maryland, if there have been any kinds of containers that people have found where they have seen mosquitoes. So I can just go to the Globe website and I can go to what's called visualize data. I can go to the map, I can take it right down to the Damascus level, and then I can look at the pictures and even see if anyone found any larvae and what kind of larvae they found. Now, I can't see who submitted the data because, again, we're not that interested in who submits it. We're interested in where the data was found. Whether you're collecting data on the clouds or trees or land cover or mosquitoes, we're interested in where they were found, not so much who found them. And here's kind of an example of how this could be important. Let's say at Shady Grove Hospital, I went to the hospital, and when they tested me, I was feeling sick. They found that, let's say, I had dengue or West Nile. Both of those are diseases that are transmitted by mosquitoes. So if people have been taking pictures of where they have found mosquitoes and pictures of the larvae, then our public health officials could go and take a look and say, I saw that there was Culex larva over here in this pond over in Damascus, and then they could go over and test the water and see if they find any mosquitoes that have that are transmitting that have the dengue virus. Once they did, then they could treat the area so that nobody else, would be getting sick. So it's just by knowing that source, kind of like we're learning with COVID, kind of learning like, not so much, I guess, with COVID, but they're interested in figuring out if, who the animal vector was and how it actually became a virus, by finding out where different outbreaks of mosquito transmitted disease occur and what kind of water sources are there, then it can help to be able to better stop it in its tracks. And then also help people to know how to make sure that they're not accidentally having places where you can have a lot of mosquitoes. I guess a quick example of that would be in Houston, Texas. There was a time when a lot of people were showing up with mosquito transmitted disease. And it turned out that there were a lot of houses that had become abandoned during a big recession that had happened in Houston, and they had swimming pools, and the swimming pools hadn't been emptied and they hadn't been cleaned. And so once they were able to find that causal relationship, then they could go and make sure that people with empty houses had emptied their swimming pools so that they weren't accidentally having these potential vectors of disease.
So, this kind of citizen science, you're really working very closely with public health officials to help with community health.
That's exactly right. And you know, they can't do it alone. They can't be all places at once. So by having us, you know, be citizen scientists and be collecting this data as we're out and about, not only can they know, you know, kind of potentially once there is an outbreak, use that information to help them know where to respond. But you know, another thing they can do is we see a big problem in a certain areas with maybe people throwing tires away and not realizing that those are potential mosquito habitats. So then that community can get in touch with, you know, whoever would be in charge of coming to collect all those tires and, you know, disposing of them properly so that they're not in the same areas where people are hiking or living and causing potential problems. So it just helps us all work together as a community and makes it easier for those who are responsible for ensuring our public health, makes it easier for them to do their job. And not only that, it's really very cool if you do find larvae, and you get one of those cell phone magnifiers. It's really fascinating to go and kind of work on using the dichotomous key to identify the kind of mosquito larva that you have.
Two more questions. One is, where do you find those cell phone magnifiers? Um, why don't we go with that one first?
Sure. And so one of the things with NASA, we're not allowed to recommend specific ones because that would be endorsing a product. But all what I will say is if you just go to, we use Amazon. That's just in kind of an easy way to, you know, to do it. And kind of see, I should have had a package of one with me right here, but it's sometimes jewelers, people who look at jewelry will have these like little magnifiers that you put on a smartphone. The ones that we use cost around $6.99 to $11.99. It's just called a cell phone magnifier, and it needs to be at least 60 times to 100 times for you to be able to, and I just put that in there, meaning that's how much it magnifies, for you to be able to use it to identify the parts of the larva that we look at to identify what kind you have.
Great. And our last question was just asking if you could review one more time the four steps. Someone had gotten the first, the third, and the fourth, missed the second. So I don't know if we could, yeah.
I understand. Yep, sure. So the first one is to identify. There's where that's where you're taking your pictures. I have a little cute figurine in my front yard that it's a girl holding a skirt up, and that's a perfect one because when it rains, she collects rain in her skirt. So sometimes, you know, that's what I will look out on Monday to just see, has she collected rain in her skirt. I can take a picture of that. It could be that when my sister was taking the picture of the hanging pretty thing, you know, that there's hung in her yard, or my sister when she had the area where the rain was collecting in her window well. All of those you just take a look at and take a picture of. On your smartphone, you'll have your location on, so we'll know latitude and longitude and the time. All of that is instantly taken care of. Um, and you don't have to add it. That's just a part of what's going to come up. So that's the first step, and that's all you have to do. On the other hand, let's say you see that there's larvae, you take a cup and scoop some out. Or you can take like a bulb syringe, that turkey baster thing, put it in a bag, bring it inside so that you're not being bit by mosquitoes, and then count how many larvae. That's another step. Another step is if you have the magnifier, go through the key and try to identify the larva and take pictures of them. Because even if you can't identify it, if an entomologist or a public health official saw it and they're concerned about mosquitoes in that area, they can look at the pictures of the larva from that area and they will be able to identify it. So as long as you have that magnifier and those close-up pictures of the siphon section of the mosquito, and we tell you how to do that of the larva, you'll be in good shape. And then the fourth step is to empty out the water when you can. You can't always do that. Sometimes because it's not your water, like I couldn't go to somebody else's bird bath and empty it. I might knock on the door and tell them if it's active mosquito season. But another would be the situation where I showed you where there was that ditch that filled with water, or even my sister's her window well. She really couldn't empty it every time there was a storm, so she couldn't eliminate it, but she could, because she wanted to not have mosquitoes, she could treat it. So those are our easy 4 steps.
That's great. Well, thank you, Dorian. This was so informative, so interesting. And I guess a question I have is when did you start using cell phones? When did the technology start working that citizen science could start using cell phones like this connected to satellites?
That just in 2017. So
Oh my
before
gosh.
that, we had, the directions written out for, say, how people could. We actually had this as a protocol within the GLOW program, but not having citizen scientists do it. But once we realized the power of smartphone technology and being able to do these protocols, have these steps that you could follow without using any special equipment. The only thing you need special equipment for is just that identifying larva. But for the other 3 tools that we have, as well as this tool, unless you're identifying larva, you don't need special tools, and we can walk you through all the steps really easily. So 2017 is when we started with clouds. Then we added mosquitoes next, land cover next, and then we just added tree cover 2 years ago. So it's been a relatively recent technological advance, allowing us to be able to gather data from citizen scientists, this easily.
That's great. And also, just to promote next week's program, could you give us just a little preview? And it'll be next Thursday, October 28th at the same time, 6:30.
I'm happy to. So one of the things that I focus on now with my job, or the main thing I focus on, is, okay, it's cool that these satellites can collect this data. How are these different kinds of data used for real world applications to help people? So another thing that's amazing is the ways in which different NASA satellite data, including data from the Global Precipitation Measurement Mission, are being used to bring food and drink to our table. So that's what I'm going to focus on. I'm going to be sharing with you some really neat ways, and also a couple of cooking shows that were developed by NASA this past summer, when we did a special focus on NASA at your table. And we were just basically looking at how NASA data are being used to improve food safety, food quality, food sustainability, and bring food and drink to our table.
That's great. Many public libraries have cooking programs and cookbook author programs. And I know our library, we're about to embark on opening a commercial teaching kitchen as part of our new makerspace. So this will be exciting to learn about. So thank you, Dorian, so much. Really appreciate it. I'm just going to bring up our final slide here and thank our sponsors once more: Nassau, the Maryland STEM Festival, Carroll County Public Library, Maryland State Library, and then we have our co-hosts: Cecil County Public Library, Howard County Library, Montgomery County Public Libraries, Talbot County Free Library, and the Wicomico Public Library. So thank you one and all, and thank you for joining us this evening.
Thank you so much for the opportunity. Have a lovely rest of your evening.